Hey everybody, welcome back to another SAT math video. This is a question from the practice bundle number 6 from 2024, module 2 of the math section. Let's begin. In the xy plane, a circle has a center C with coordinates h, k. Points A and B lie on the circle. Point A has coordinates h plus 1, k plus root 102, and the angle ACB is a right angle. What is the length of the line A and B? So for these type of geometrical problems, it's usually very helpful to draw it all out. So what I'm going to do is just move over to this side and let's draw out what we know. Okay, so we have some circle, right? Some circle with the center point of C, and around C we have a circle. That'll do for now. And on the circle we have a point A, right? So this is going to be our point A. And then we also have a point B, right? Somewhere else on this circle, right? We got some point B. And they're telling us that the angle that is formed by A, C, and B, that is a right angle, okay? So that's what they told us, right? Whenever they give you an angle like this, usually the angle is formed in the way that you read it, right? So ACB means the angle is going to be ACB. Our angle is here, okay? And they also tell us that C is the point H, K, and then A is the point H plus 1, K plus root 102. So this is what we know, right? Now, what are they asking us? They're asking us to find the length of AB. So that means they're asking us to basically calculate what is the line or the distance between A and B, or the length of the line that connects the two. So we will try and figure this out, right? So let's just first analyze what we can glean just from the diagram, right? Well, right off the bat, looks like a right triangle, right? So that's something that we can use later on. Also, given that this is a circle, right? We know that any point from or any line rather, from the center of the circle to the circumference or the edge of the circle is a radius, right? So we know that the line CB is a radius, and similarly, the line AC is also a radius, right? So if we're able to figure out the distance of, or the length of R on one leg, we can find automatically the length of the other leg because they are the same. Okay, so now let's try and figure out what R actually is, right? So we know we have 2 points, right? And we need to basically find the distance between this point C and this point A. If only there was a good formula that we could use. Well, lucky for you, there is one. It is called the distance formula, right? So you might have learned this in like pre-algebra or geometry, but here's what it looks like. So the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. All right. You can find a proof on the internet if you are interested in how to derive that formula, but suffice it to say, this is as far as we'll get into it for this video. And now we know that we want to find the distance r, right, or the radius of this circle, right? So what we're going to do is basically plug in the points that we know, right? So we have an x and y point here, and then an x and y point here. So let's just plug all that in. So D is actually R, right? So we'll just make that a little bit more clear. D is the same as R, right? Which is going to be the same as the first x point, right? So we have our first x, h minus h plus 1. So I'm going to write that in brackets here. H plus 1. And remember, that's all going to be squared. Plus y1, which is going to be k minus our y2, which is going to be k plus the root of 102, and this one is all squared, okay? So all we got to do now is simplify. So let's do this one step at a time. H minus h, that's going to cancel out. And then we're just left with a minus 1, right? Because this minus symbol we had over here is going to carry over. So then we are left with minus 1 squared. And then let's look at the other parentheses. K minus k, that's going to cancel out both k's. We're left with a negative 102 squared. So a negative squared becomes a positive, and then a square root squared cancels out the square root, right? So we are left with positive 102, and that's all going to be under the square root symbol, right? Let me clean that up. Now we can simplify even further. So minus 1 squared, that's just going to be 1. So this becomes basically 1 plus 102 all square rooted. So in other words, our radius is equal to the square root of 103, right? So now we know what the value of r is. Can we now figure out what the length of AB is? Well, the answer is yes, we can now. Because remember, this is a right triangle, right? And right triangles have some special properties, right? So one special property that comes to mind, and I'm sure you've heard of before, is the Pythagorean theorem, right? So I'm going to just move over a little bit here. So the Pythagorean theorem, if you recall, basically is a squared plus b squared is equal to c squared, right? Where a and b are the legs of the right triangle and c is the hypotenuse, right? So we know the legs, right? Because we have r and r. We just want to find the hypotenuse, which is ab, right? So all we got to do is plug in our value for r and then solve, right? So let's look at what we got. We got r is going to be 103 squared plus 103 squared is going to equal c squared. These cancel out, right? So then we're just left with 103 plus 103 is equal to c squared. Otherwise, 206 is equal to c squared. So c is equal to the square root of 206. And what I did there is to get c all by itself, you just have to square root the squared. Those two cancel out. And whatever you do on one side, you do on the other side, right? So our answer c is equal to 206. And remember, c is nothing more than the hypotenuse, right? So that means AB is equal to root 206, right? And is that one of our answer choices? Let's see, right? There it is, right there. So that is how you solve this one. Now I'm going to go into another method as to how you could find AB once you solved for R. Notice again that we have a right triangle, right? We have this right triangle, and the right triangle has two lengths that are the same, right? Two legs that are the same. Let's just call them x here, right? And x here, right? Notice, I'm sure if you saw at the beginning of the math module, there were a few special right triangles whose relationships were defined, as for your reference. This too is a special right triangle, right? We call this one a 45, 45, 90 triangle, right? Because both of these, if these two side lengths are the same, that means these two angles would have to be the same. And if these two angles are the same, the only possible degrees that they could be would be 45 degrees, right? So, meaning, if we know that this is x and this is x, the relationship for this type of special right triangle would be the hypotenuse is going to be x root 2, right? So if we wanted to solve it a different way, we can also use this property of special right triangles and just kind of plug in our value of x and simplify to find the hypotenuse, right? So similarly, if we know that x is equal to r, which is equal to the root of 103, then our x root 2 would just be equal to 103 times root 2. And whenever you have two radicals or two square roots multiplied with each other, they're simply just the product of what is underneath the square root symbols, right? So that means x root 2 is nothing more than 106, where x root 2 is our hypotenuse, right? So, I'm sorry, that it should be 206. My bad. So that's just another way that you could find the answer once you had the value of r, right? So those are two ways that you can use. Feel free to try out whichever one makes more sense to you. As always, thank you so much for watching. If there's any way that I could improve these videos or make these more useful for you, please let me know in the comments. Check out Khan Academy, of course. They have a plethora of good resources that you can use to get a great SAT score. I'll see you all in the next one.